Next topic is transformations. Transformation means that modify the domain variable. Usually domain, I said that the time or space. Okay, so how we gonna modify the domain variable and what's gonna happen. The first one is the time shifting or time scaling. The first one is here shows the time shifting. If you're changing the time variable like this way, then this one is a parallel shift along the domain variable. Here it shows two different curve, just the shifting. Okay, I would like to show you that the effect of time shifting. Okay, I choose time shifted value. Okay, first time shifting is 0, then it overlap each other. If I shifting 0.1, then a little bit shifted along to the right hand side. Okay, if I move a little bit more, shift more, and 0.5 moving 0.5 point. So this is a time shifting. So you can see that what the relationships. It's a parallel shifting. The time shift is just shifting the domain variable. Okay, it's the same to the discrete time. Okay, discrete time shifting can be expressed in this way. And time reversal case is just a reflection with respect to y, across the y. So this can be explained in this way. Here, if I would like to scale factor. Okay, we turn it on. So if scale factor becomes the -1, then this one shows that the reversal signal at this moment a equals -1, means that if minus xt is a reflection with respect to the y-axis. Okay, see here. So the blue one and the gray one as a reflection image of the with respect to y. Okay, and the last one is scaling. If we give time scaling and domain, it can be shrink or expanding. So here is the xat, a equals 1, then it's overlap. But if we increase that 1.2, that's the shrinking. If increasing 1.5, further shrinking. If we're taking smaller value like 0.9, it's a little bit expanding. Okay, 0.8, further expanding. That's the scaling. So we talk about the 3 different time domain transformations. One is the shifting, another one is reversal, and the time scaling. We talk about the 3 different time domain transformation. Okay. Topic is periodic signal. What is the periodic signal? Here shows the definitions. For all times, if xt are equals to xt plus t, if signal satisfy these conditions, the t is called the period. Okay? Here shows that one of the periodic signals here. So every time t, the same patterns are repeated like this way. This is periodic signal, and what does that mean? The periodic period means this one. Okay. In case of discrete times, it's the same. For any n, xn should be equals to xn plus n. So in that case, n is a period. So periodic signal shown here. That you can see that the 1 1 minus 1 is repeated like this one. 1 1 minus 1 1 1. So that is repeated patterns. Okay. This is the definition of periodic signals and what does that mean, the period. And next topic is what is the even and odd. The even signal means that if we take a reflection with respect to y-axis, it should be the same. So the minus x minus t are equals to xt, or x minus n are equals to xn. That is the even signals. In case of other signal, it's a symmetric with respect to the origin, not by the y-axis. Okay, so if take x minus t, then it should be minus xt, or x minus n should be equals minus xn. So to satisfy these conditions, this signal should be 0 at t equals 0 or index equals 0. If it is not, this does not satisfy. So other signal always passing through the origin. Okay, in any given signal can be decomposed into the even part and the odd part. If xt is not even nor odd, but if you're taking the average of them, xt plus x minus t, divide by 2, that becomes the even part of xt signals. The odd part of the xt signal is just take a minus x minus t, that becomes the odd part of the signal. So xt can be decomposed into even part and odd part. If you take the minus t at this even part, then that becomes the part of the xt. And if you take a negative value at here, that becomes the odd part of the xt. To verify the one, here it shows, okay, here it is. So xt itself, okay, xt itself is not even, not odd. Okay, this is the xt. Okay, xt is not even nor odd, but taking the average of that one, you know what, xt and minus xt at here, that minus 1, then this becomes minus xt. Xt and minus xt, by taking sum and divide by 2, that becomes the even part of the xt, and by taking difference, that becomes the other part of that one. So plotting that one shown here, so the blue one is the even part. Okay, I'd like to make present. Okay, the blue one is even, but the orange is other part. So the xt, the original xt can be decomposed into even and odd one. Okay, so at here you need to know what is the characteristic of even and what is the odd, and if there is a signal is given, then how to decompose into even part and odd part of the signal.